Alright, so we're going to go over factoring trinomials. For example, let's take a trinomial of this kind where the coefficient in front of the square is a 1. If we were to have, for example, x plus 2, take x plus 2, just x plus 2, and multiply that by x plus 3. These are two factors. These are what we called two binomials multiplied together gives us a trinomial. If I were to multiply it, x multiplied by x would give us x squared, and x times 3 would be 3x, and then 2 times x, and then 2 times 3 would be 6. If we were to combine like terms, this would give us x squared plus 3 and 2 is 5x, and then 6. Okay, factoring this will give us this. These are the factor form. So we could say this is factored. Okay, so the objective here is to transform this into that. So let's take another example, very similar to that. Suppose I have x squared plus 6x plus 8. Our objective is to get two binomials here. Now we know that we're going to get an x and an x, and then everything in here is plus, so we're going to get a plus and a plus. So what do? Well, we take the coefficient of the end right here, which is the 8. The middle coefficient is 6. And the idea is to find the factors of 8 that can add up to 6. And clearly, the factors of 8 are 1 and 8, and 2 and 4. As you can see, 2 and 4 add up to 6. And 2 times 4 gives us 8. So we can actually write x plus 2, and then x plus 4, which is what we need. If I were to multiply back, x times x would be x squared, x times 4 will be positive 4x, and 2 times x will be 2x, and then 2 times 4 will be 8. Now if I combine like terms here, this will give us x squared plus 6x plus 8. Okay, so let's do one more example, a few more examples, just so you can see what we're doing here. Alright, so let's take, let's say we have a squared plus 8 times a plus 15. Again, we start by using the Dimond method here. The 15 goes on the top, the 8 goes on the bottom, and the idea is to break down the 15 into factors that would give us 8. So we know that 1 and 15 doesn't work, and then 3 and 5, 3 times 5 is 15, and we know that 3 plus 5 will be 8. So clearly we can see that x plus 3, multiply that by x plus 5, gives us the two desired factors. Now how do we know it's true or not? Well, we multiply back, we do the check. X times x will be x squared, x times 5 will be 5x, 3 times x is 3x, and 3 times 5 would be 15. Again, combining like terms, this would give us x squared plus 5 plus 3, which is 8x, and plus 15, which is exactly what we started with. Oh, I changed the variables to x, but So we can just change the variables back, because I prefer x's for some reason or other. This would be 8a plus 15. Okay, so let's try one more. Hopefully this time we'll keep the variables the same. Suppose we have something like 9 plus 10t plus t squared. As you can see, this one is in reverse order, but because everything is positive, we can just rearrange it and write it as t squared plus 10t plus 9. Again, 9 goes on the top, 10, the middle coefficient goes on the bottom. Well, here this looks weird. What are the factors of 9 that would give us 10? Well, 1 times 9 and 3 times 3 are the factors. 3 times 3, 3 plus 3 doesn't add up to 10. It does give us 9, but not 10. 1 times 9 is 9. 1 plus 9 gives us 10. So here we can actually go right into it and go x, or rather t plus 1 and t plus 9. Again, multiplying back, we can go t times t is t squared, and then t times 9 would be 9t, and 1 times t, and then of course 1 times 9 is 9. Combining like terms gives us t squared plus 9 and 1 is 10t, and positive 9, and of course this checks. So the factors are t plus 1, t plus 9.